Not really.
Okay. Um, so like, what kind of things have you been covered in class recently, and like, I guess what are you covering next?
Oh, actually, can we go over like object-oriented concepts
Yeah,
like inheritance?
sure.
That's better, yeah.
How much have you guys? How much have you done any of that in class or anything, or on your own?
Um, we've already gone over it a little bit, like a lot,
Okay.
but I'm still not sure about some things.
Okay. Sure, we can do that. So, just as like a brief, like, define maybe like, what do you know about like inheritance, and like, what does inheritance mean?
Well, like if you had like a super class named car,
Hmm.
a subclass named like Mercedes, like
Hmm.
car, like that constructor can go into Mercedes as well. So Mercedes inherits that, inherits all
Hmm.
its methods.
So
And then
why?
other like,
What? Sorry, go ahead.
oh wait, what did you say? I'm sorry.
Sorry, go ahead.
Um,
Keep going.
and yeah, and there's other nitpicky things I'm not really sure about.
Okay. So what is like the reason why you have like a separate car class and then like all these subclasses, like a subclass for Mercedes? Why wouldn't you just why wouldn't you want to just have a class called Mercedes and not deal with subclasses?
I guess it's like it helps with like just like design and such. Like you don't have to copy methods or duplicate code.
Yeah, that's one of the major reasons. Especially like if you have like if you're just doing Mercedes, then maybe you don't need to make it a subclass, but there's like 100 car companies or whatever, so recopying that
Mm-hmm.
code in every time is going to be really annoying. And then it also is like can be a bit can make it harder even because you have to like keep track of all those things. So it's easier to just so yeah, that's one of the major reasons. So you don't have to copy code and you can keep the relationships. So you know that every sub like if you have a Mercedes subclass and you have like a I don't know a Honda subclass and like a Toyota subclass,
Yeah.
you don't you know that they all have like those car methods, so you can treat them kind of similar. That's kind of the point of object oriented programming.
Mm-hmm. I understand that.
Right.
Is there other
So
reasons?
inheritance. Sorry.
Is there other reasons why?
A lot of things kind of fit into that. So there's things like polymorphism. So you can if you have like a list of car objects, you can kind of
Yeah.
like have them all drive even though they all drive differently or they all have different features.
Mm-hmm.
So mostly a lot of things like that. And then also like say you write a car class and
Yeah.
you write all the like subclass at first, but then say someone else comes in with your code, having like
Yeah.
that car class that like lists you have to have these functions will like kind of like enforce standards and make sure everything like makes sense and everything's following the same rules.
Oh, okay. That makes sense.
Right. So
Yeah.
so what if you don't have a parent class? What happens?
If you don't have a parent
It-
class,
can you? can you not have a parent class at all, or like
I mean, I think you need in a hierarchy. Yeah.
right? So if you don't have a parent class, there's actually an object class. So any class you make has to like fall under the object class. So even if
Yeah.
you
It's
have
called
like a
yeah.
so even if you have like a vehicle class here and you have like children, like car class and motorcycle,
Mm-hmm.
like at some point in like the chain of children, in the chain of parents, at the top has to be object, and the object gives some features that all classes end up having.
Yeah, I get that. Like dot equals.
Hmm. Exactly.
Yeah. All right. Yeah, I get that.
Okay, so I think you get the some of those basics. You can skip ahead.
Mm-hmm.
So right, so the dot equals like we talked about. Do you remember that? What is the point of that?
Dot equals compares to objects, unlike double equals, which it
Hmm.
only compares memory locations. So it's just divided.
So I guess like kind of like walk me through like, do you understand why that happens or?
Like why that happens?
Yeah, like kind of like what in how is like what happens when you do like dot equals and what happens when you do like equals equals?
Well, you can't use equals equals in certain circumstances, but when dot equals happens, I know it's like overriding the objects, an already inherited object that all objects have, so we can use dot equals instead of equals equals, which is only used for primitives. And yeah, I don't know what else.
Okay, so let's just walk through some examples.
Okay.
Um, so in this case, which of these with the dot equals, which of these are gonna return true?
So P1 equals P2. I guess it will be. Is it P3 that equals P4?
That is the yeah. So you're saying that one will be true
Yeah,
and the rest will be false?
yeah,
Exactly right.
yeah. Oh, okay, I understand. So if it was equals equals, it would have returned true because it only checks memory locations. But does it like so it says
See, like even though person one and person three have the exact same features, dot equals dot that dot equals only works still thinks that they're different because they're different at different locations. I think you might have flipped them if I understood what you're saying.
oh okay, yeah, I think I flipped them. Yeah. Okay,
Yeah.
I get it.
So um you can you can make your own equals method
Mm-hmm.
um that kind of so so you were right. Um
Mm-hmm.
sorry, I didn't you weren't backwards, but what happens is for like you have to if you want to override this if you want the dot equals to like treat it like if the strings are the same or if like the names are the same or something else,
Yeah.
what you have to well in that class you have to override equals.
All right.
So what you have to do is
You
so
have to.
the string class already does that for you because it's like a class that's already given to you.
Mm-hmm.
But in this person class, you would have to have like a method that is equals, and it would then you would have to do some sort of logic to check if they're the same person. So here,
Yeah.
they're checking if they're the same string for name.
Yeah, I see that. All right. Yeah, that makes sense. Okay.
So how come how come like how come this dot equals works? Okay, sorry. That was a bit confusing. But let's say you had like a name class,
Okay.
um, and that like held um that that was just some type of class that held like a name and maybe some other information. Would
Mm-hmm.
you be able to do um would you be able to do like this
Dot this
dot
dot.
name dot equals this the other person dot name?
I don't. Maybe not. I mean, it's private, so well, no, we can still ask if it's private. But maybe we would.
Like and
To
remember like I guess I should have ran it first. So when we do string, this works, right? Because it's saying P1 equals P3. So these two people, both named Gabe, are equal because they have the same name.
Mhm. Yeah, I checked.
But
Yeah.
so right now we're comparing them with their like string names. So what if you had like a separate name class
Mm-hmm.
that contained like a name
Okay.
and you tried to compare like this? Would that work?
I think I don't know because we're already overriding equals to like set it to something. So
Right. And
and
let's
that's
just
so we
say
have that.
we had like a say we had a public class, name class.
Mm-hmm.
Um, so that contained all it contained. Let's just say all it contained was like a constructor, basically.
Yeah. Okay.
Yeah, let's just pretend it had like a constructor.
Yeah. Name class. Yeah. What
And
are
let's
yeah.
say it doesn't need to take in anything, but you get the idea, right?
Mm-hmm.
It has a constructor, and that's it.
Okay. Oh, it just has an empty. It just has a default constructor. Okay.
Yeah, or even if it had like a basic constructor,
Mm-hmm. I get it. Okay.
or I guess I can just build it out. It might be better to build it out. String name. It has a private field, private string name,
Mm-hmm.
and so it would be name and follow the same type format where you just set this dot name
Well,
equals name,
yeah.
and you get what this is doing. It's just
Mm.
you get what this line in this constructor is doing.
It's initializing the field to the variable name.
Right, exactly. So say you had like a name class that did this,
Mm-hmm.
then would this work? Do you think?
Um, will the name class work?
Uh,
Um,
yeah, I'm trying to get the name class to work. So if you see anything that
I
would
don't.
make it not work, let me know.
I mean, I think it would work just because like it's already it already is doing dot equals and it's checking for each name. So I assume it would
Right.
work. Oh no. What happened?
Maybe if it's like this. I'm not sure exactly if it'll let me do it here.
Okay.
Um, hmm. Yeah, I'm not sure if it'll let me do that in a file like this. Um,
Okay.
but so basically, I guess what I'm getting at is
Mhm.
what this is doing is if instead of a if instead of a string, like this dot name used to be a string, right?
Yes.
So instead now it's a name class. So
Mhm.
it's doing like, is the first name class equal to the other name class?
Okay. We're comparing classes.
Yeah, because it used to be, is this string equal to this other string? But
Mhm.
now instead we made the name variable a name class instead of a string class, right?
Yes. Oh,
That
okay.
so because name class doesn't override equals, it would still have that same issue.
Yeah. Oh, okay. So it has to also have that in name class.
Right. So the reason why this was working was because string overrides equals already. So
Yes.
it was overriding this equals with the like actual, like looking at the two strings. But
Mhm.
name class can't compare those because it doesn't override equals.
Okay, I understand. We definitely have to pay attention to that.
Yeah, I mean, yeah. Hopefully you don't have to do too much of that on the exam or anything, but 'cause I know that can be tricky. Oh, there was a okay.
Overloading.
Okay. Overriding versus overloading. Do you remember which one's which,
If we're talking
or
about,
have you heard of them?
yeah, like overloaded methods, yeah.
Hmm.
Yeah.
Okay. So which one is overloading methods?
Overloading methods is like, let's say that like you have like a fraction class, and
Hmm.
then you have like this one that's, wait, let me try to understand. It's like it kind of like is like calling its, not really calling itself, but like it has like the class name inside of it. Like,
So let me give me 1 second. So kind of just like tell me what you mean. Kind of like I'll write it out. Do you have like a fraction class?
fraction class, and then like I was trying to get at like you had a constructor or like a default constructor, then I thought you have like another one.
Okay. So you have like a public fraction.
Mm-hmm. And then
So
like,
something like this
yeah,
or something. And then you had another constructor, you're saying?
oh no, like not another constructor, but like let's say like fraction had like you could like add fraction, you know, you can add fractions, right?
Right.
And then like let's say like you have only one that like takes like another. I don't know. We did this in class one time, and I'm trying to like describe it because I remember it.
Do you mean like this, maybe this one takes in one fraction? I guess it would be like a double, so frac. And then
Yeah,
you're saying another one takes in like two and adds them together? Is
yeah. So
that what you're saying?
like I feel like say so you can do like public. That was really what I was saying mostly, but I was thinking about like you have like the add method, right? And that's for
Okay.
fraction class. And then I thought you have
Y-
another method that takes takes fraction as a parameter, and then after that it has like other or something in it. Yeah, like public add. Like the first one has int m or double m, whatever. And then after
It
that you
has
have another.
it's just one int and then okay.
Yeah,
Anything
and
else
then
in
after
here or
I'll
just
just
one
keep it like
parameter?
that.
Okay.
Yeah. And then after that you have another add method that says like fraction other or something like that.
Oh, if you have like a fraction class, so this one takes in a
Yeah.
fraction. Oh, okay. I see
Mm-hmm.
what you were saying earlier. Okay, yeah,
Mm-hmm.
that's right. So you have basically you have the same method name, but you have like different parameters, or you might have one that has zero
Yeah.
parameters, one that has one parameters, and stuff like
Mm-hmm.
that. Yeah. Okay, that's right.
Yeah.
Um,
Yeah. Like,
you
yeah.
remember
Different.
overriding is, or have you seen overriding?
Yeah, like we were doing it just with dot equals. Like we can override dot equals and from the object class. I mean, if it's
Exactly.
yeah, it's just like let's say like car had like a method like drive, and
Hmm.
then Mercedes can get that, but they can like override it and put their own thing that's only good for Mercedes. So you can
Right.
override that, right? Yeah.
Exactly. So
Yeah. Okay.
I understand with Mercedes and car because Mercedes is like the direct child of car, but how come what were we overriding when we did equals? Because you could have a class that, right? What were you, what was the, okay, so we were overriding the original object, right? Object
Yeah.
dot equals?
We were. Yeah. Yeah.
Okay, yeah, so I was trying to like phrase that as a question, but I couldn't come up with a good way, so,
Okay. Yeah.
okay,
That's fine.
all right.
Okay, so
And overloading. So here's an example question that we can
all right.
kind of,
Yeah.
hard to read.
Mm-hmm.
There
That's
you go.
better. Yeah. Okay. So the following declaration in person will quickly overload the method person. So student extends person. So that means a student is a person. And then so overload the get food method. I guess you would do B.
B.
Yeah.
So what made you say B?
So like in
So like walk
person,
me through it.
yeah, person it has the method get food, and it
Mm-hmm.
just has no parameters and it says return hamburger. And then student is a person, but if we want to also have let student have the method and we want to overload it with a different parameter that's only for student, we would
Oh, sorry. This
probably
says override. Actually, we want to override the get food method, not overload it.
oh yeah. Okay, wrong. I said it wrong, but like if we want to override it for only for student,
Mm-hmm.
we would have to add another parameter for student, so it's in quantity. So overriding it, yeah.
Remember, overriding is the one where you have the exact same method as in the child class as the parent class, and that way it
Yeah.
does the child. So that way it does the child class one when it can. So like in the dot equals example, you
Mm-hmm.
um you had the exact same method, like method name, the same parameters, but you were able to overwrite it because even though it was the same method name and parameters, because whatever your like the string class or whatever is a child of the object class, it can override that. So
Oh,
if you
okay.
yeah, so to override this, you need to have this exact. You want to copy this exactly.
Okay, I would do C then. I think I got mixed up with overload.
Yeah,
Yeah, yeah, because
yeah, that's like a very
um,
classic CS mistake. Mixing.
yeah, because
I always confuse
okay,
myself. Yeah.
yeah, I'm thinking about dot equals now, and I know. Okay, I understand. Yeah. Okay,
Okay.
so
So here's if you want to overload it. So then if you want to overload it, then you were right. You would B would
oh yeah, then
B
it would
would
be yeah.
B would do it.
That's true. Need to get that into memory. Okay, that makes sense.
Hmm. So um, one of so kind of the thing with overriding is it can kind of like be counterproductive, right? Because the whole point of like inheritance and stuff is that you don't have to rewrite the method every time, right? So
Uh huh.
if you want to if you just override the previous method, the parent method, then
Mm-hmm.
you have to like basically rewrite the method from scratch, which sometimes you have to do if the method is very different. Um,
Okay, that makes sense.
but
So,
so you, yeah, go ahead.
oh no, I was just gonna go into like what we're doing right now, super. Like, I said
Right.
that before.
So yeah, so the super is kind of helps. It helps you. It basically you can access the parent class information from there.
Mm-hmm. So you
So
would call that in the child class?
yeah, so say like say for get food, you want to return like say for students. So in the person class to get food, that just means get a hamburger. But
Yeah.
if you if you're a student, then you want to get a hamburger and a taco. So
Uh-huh.
instead of here just writing a separate like method, you can
Mm-hmm.
you can when the child get food method get called, you can first say, okay, first do what the parent says to do, which is to return hamburger.
Okay.
After that, then um you want to yeah, then you can do the rest from child. So that would I mean, in this case, obviously, it doesn't really save you much time or effort. But if this was a lot longer and this did like a bunch of other things, you wouldn't have to rewrite it or copy it over. You could do the person get food, then do the student get food.
All right. It'll be more concise. I get the idea.
Mhm. And it's like similar things for like constructors and things, right?
Mm-hmm.
So just because you're a student doesn't mean you don't have a name. So in the person constructor, you assign your name. So here you would do that same thing. So you would, since you're doing that same thing, you can, if you do super, um,
Yeah, super. Then the method name. I mean, the parameter
mhm,
name we put in there. So
mhm.
that's what it's called when they call the constructor from the parent class.
Yeah. So do you realize? So why is like kind of this format is different than this format, right?
Mm-hmm.
And here you're doing super, then parentheses and something, and here you're doing super dot a method, right? So
Yeah.
what's the difference between these two things? Why are you doing it one way here and another way here? Do you have any idea?
Well, we did dot get food, and that was a string method. But instead, we did super and the name, and in person, I think because like in the constructor in person, there was the name as well as for the constructor, so we're calling that into students as well because they have a name, so it's the
Right.
same.
So the big thing here is when you want to do a constructor, you would do this
Mm-hmm.
um, you kind of do this format. So you do super within the parentheses, and
Mm-hmm.
that calls the constructor for the parent. If you want to call like a method for the parent, then you would do the super
Got
dot then method name.
that makes sense. Okay.
Right. Okay. Um, so just to check your understanding, uh,
Mm-hmm.
so what would this constructor do, kind of?
So for student, it's gonna call the parent constructor the name, so it's gonna initialize the name to its name, and then also it's gonna set ID to
Hmm.
next ID, and that next ID plus plus. So I guess it's like assigning IDs to students, so each
Hmm.
person gets a different one. So it's just
Right.
incrementing by.
And
Mm-hmm.
yeah, this is like a. So do so what do you know what the static means here?
It means that it's shared by all classes.
Close. It's shared by all instance of this class, kind of. So
Oh.
every time you make a new student,
Mm-hmm.
they all have access to this variable,
Mm-hmm.
kind of. Yeah, that's kind of like a simplification a little bit, but
Mm-hmm.
you do the next ID plus plus. So even though you have like different objects, different students,
Mm-hmm.
each one gets a
Yeah.
unique one because each new person bumps up the next ID to what by one.
Yes. Okay.
All right. Here's another problem.
Okay.
And this one uses the supers and some overriding concepts.
So base. So what is the result of B dot method one? So B dot method one. So I guess.
And if you want to just like walk me through it or like talk out loud, that would be helpful.
All right. So we're creating a new type base called B equals new derived.
Hmm.
So it is a result of call B dot method one. So is in the derived class, but it's also considered a base. So if we do dot method one, if we go down to derived, we do super dot method one. So we have to go back to base.
So why does that? Why did you start it derived, right? Because it's called a base here, but it's also called a derived. So how do you know which one is what it actually is?
I think it's new derived. So because that's the class, but it
Right.
also is the base. So yeah, but we're also
So
making.
so why do you know why does this like work, right? Because shouldn't it not work if it's a derived? How come you can call it a base?
Because derived extends base.
Right.
Eh,
So will it act like a base at all, or will it? If I made this, if instead it was like derived b equals new derived, would that change how the function worked, or would it not?
It would not. It would just act like a derived, but it also extends base. And
Okay.
method one, it calls the parent class
Hmm.
constructor. So we have to go back to base. So I still think it will like go back though. Yeah.
Right. Yeah, because this is only at compile time that it thinks it's a base. When it's running, it knows it's a derived. So you're exactly right.
Oh, okay. So so b dot method one. So we're in derived, public void method one, super dot
Mhm.
method one. We're going back to parent constructor method one and system dot out dot print a. So we print a, yeah.
Mhm.
So a, and then method two. So we go down to method two in base, and we print b. So b, and
Mhm.
then we finish that, and then system dot out c. Hmm. I'm kind of confused of which me- method two actually. Is it b or d? Is it going back to the parent or is it going to the derived?
Right. That's a tricky question. So it's gonna try to go to the derived one first because that's what it actually is. So even though it's like it kind of goes up here when you're like thinking about it and looking at it,
Mm-hmm.
in reality, it's like it goes up here and then and then it's still like and then when it sees method two, it just first it always checks the derived and then we'll check the base. So it'll try to do this. It'll go to this method two before this. It'll try this one. If
Yeah,
that
that
makes
makes
sense.
sense. So instead of so let's put A B.
Hmm. And then
So I guess
it'll do method two. Then where will
yeah,
it go?
C. Then it's gonna print C again. So I guess it's B.
So what was that? So it's gonna print A. So then it does method two. So then which method two will it go to?
So I guess it's going to the one method two in the base class because I don't know if it goes to the method two in that one because if it does if it does the super dot method one in the beginning, and if that constructor calls method two that's in the same class as it, I think it will just print B then, right?
Well, it's when it calls a method, it's still no like it might have be doing a method from the base class, but it still knows that it's a derived. So it's still when it sees that method too, it's still gonna try to do the derived method too.
Okay,
And
but
we can run through it with this example. We can step through the code.
mm-hmm.
So we're gonna call b dot method one.
Mm-hmm.
We're gonna go to the derived one first.
Yeah.
Then we're gonna go up to print a. So this is all like we talked, like you thought of earlier. So it's gonna print a. Then yeah, method two. It comes down to the derived one instead of the base one because since this is a derived, it tries to do the derived method two first.
All right. Okay.
All right.
Okay.
So now that we know that, what do you think will happen?
Okay. So I'm sure A is printed method two, so it goes on to derived
Mm-hmm.
method two, and it says super dot method two. So okay,
Right.
so we're going to the parent constructor method two, and we print B. So B is printed. Then we go back and we print B to finish off method two, and then we go back to our original method and then print C. So B.
Exactly right.
All right.
Yeah, that one's a bit tricky.
Mm-hmm.
Okay. So have you seen like have you seen these like so you know when you like make a class and things you have to either say like public you have to put like public class or something class, right?
Yeah.
Right. So what's like the difference between like public and private? Like when do you get to see what?
Well, private are mostly for fields, and those are mostly just specific to the class, and it's not visible to anybody. So it's like process encapsulation, pretty much, just like data hiding. But we can initialize the fields in the constructor, so
Hmm.
it can be used in that class, or if it uses other classes, then it can be initialized somewhere else in methods and such.
Right. Okay, yeah, that's a good answer. So have have you had to use like setters and getters? I think they're called. So like either
Yeah.
like get the name or set name and stuff like that.
Yeah, to like change or like get the name so it can be accessed in other classes.
So instead of making this private, why wouldn't you want like why don't you just make this public so you can easily you can because if you make this public you can just do like dot name you can just do like dot name or to get it right. So
Mm-hmm.
why do you leave it private and use these like get name functions instead?
I guess it's just that it's like a characteristic of a class. I'm not really sure like what else like there is.
Yeah,
I mean,
it's just the one of the reasons why you might want to do that is like in this example. So for this set name,
mm-hmm.
um, like you want to like it's not always as simple as like set the name to any string or whatever, right? So you might have to like here they do checks, make sure that the string provided isn't null. You might want to do other things like check to make sure that it's like if you're making a website, you might want to say like, okay, it has to be under 100 characters because after that, something else in my code breaks. Or say you have like some code, like a class that's like a person class, and you have like age, you might want to say like it can't be negative, right? Age can't be negative.
Yeah.
So with this gives you like more control with these like setters and getters because
Mm-hmm.
then you can say you can make sure that the data coming in is actually like in the right format and makes sense and it like fits your conditions before like adjusting it.
All right, that makes sense. That's more clear.
Yeah. Oh, one thing I wanted for the static earlier, um,
Mm-hmm.
I was giving I gave kind of like a bad incomplete description of it, I guess. So one of the other things about the about static, what that means is you don't need to like instantiate the class to activate it. So it's
Mm-hmm.
kind of like uh, if you've ever used like the math class in Java, or I think there's some other classes where you don't want to like have to make like a math object to do everything. So you can just use static functions. Like I think like there's a random class, so like you can do random dot random, and then that way you don't need to like make a random object.
Oh, okay. So,
So yeah, so it basically it makes it so you can if it's a static method or a static field, you can access it without instantiating the class.
all right, that makes sense. Yeah.
All right.
All right.
Yeah, so then this becomes kind of a pain, right? Because if it's a private field, then you can't just um
Change.
you can't just set like this dot name equals that or whatever, right? So you want to,
Yeah.
so you can, in your constructor, if you just, as we talked about like kind of earlier, if you just put in the like parent constructor, then the parent, since the parent constructor does it, it'll just do it for you, and that way you don't need to worry about access.
Oh, okay. Yeah. Yeah, that makes sense. Yeah.
Mm-hmm. And so Java also has this rule that for your constructors,
Yeah.
uh, you have to um, um, that you have to in the first line of your constructor of a subclass, you have to have add a super call to the parent class, because in order to be a child of the parent class, you have to do the superclass stuff. So,
Well, that makes sense. Yeah.
so
Okay.
if you have like a no argument, if you do like a no argument, or like if you do like a blank constructor,
Yeah.
then you would have to, it'll like it can automatically do it.
Mm-hmm.
If it's like a no argument constructor, but that's something you might want to watch out for. So here's an example. Here's a question asking about that, so you can double check.
So moving on in the point 3D class. So, and it is point T. So, I mean, it could have a blank constructor just like with nothing in it. So I guess I will work. I mean, number one would work.
Okay.
Two as an X, Y, yeah. Then it has super XY, so it's getting that from the parent class. And then it just initializes Z to something else, to the field that it already has. So that would work.
Okay. Mm-hmm.
And then it has that XY. Then it says this dot D equals 0. I think that would work as well, just because Z is a field in point 3D. And even
Sorry, are you talking about 2 or 3
but
here?
I'm talking about 3 right now.
Okay.
But I'm kind of confused because it didn't call super.
Right.
Yeah. But it did call Z, which is 0.
Mm-hmm. Yeah. So be so
But point 2D has a no args constructor though. So I think that it would just like call that anyway, right?
mm-hmm.
Even if it is a or like we just said. Yeah.
Right.
So I'm guessing they would work all work.
Yep. So all 3 works.
Yeah.
Yeah, I think I was a little bit um, confusing in the explanation for that, so I'll just like make sure it's clear. Um, so yeah, so if the subclass doesn't call the superclass in the first line in a subclass constructor,
Mm-hmm.
um, then it'll automatically add a super in the front.
Yeah.
Yeah, so you to a no arg constructor. So if the parent class didn't have this, then it might have been, then the third one might have had an issue.
Yeah,
Yeah. So,
all right.
and we can kind of change some things around just to show that.
Okay.
So right now this is using on for one, like we talked about, but let's edit the code. And if we are using the third option 3, and we were doing
Yeah.
this one. So if we did this right now, we know it would work, right? Because we because it fixed that. But if we got rid of this no arg constructor, then it would
Yeah,
then it
there's
would
an
throw the error.
Okay, that's always like a really picky rule. So yeah.
Yeah, it's something like people usually forget about because it doesn't always come up that often, but it's a good thing to know.
Oh, definitely.
Just give me 1 second. I just had to turn on the lights. All right, I'm back. So yeah, is there any of these topics that you're still confused about, or anything you wanted to specifically else you wanted to jump in on, or we can keep going, or we can do some practice? Kind of, it's up to you.
Can we do interfaces? Inheritance
Sure.
Yeah, I'm pretty solid on abstract classes. So, but
Okay.
sometimes I
Yeah.
just don't know what
Yeah.
interfaces.
Yeah. Interfaces and abstract classes are very similar, and you can,
Yes.
I don't know, for a lot of cases you can use one to do the other, or you can use an interface to do what a lot of abstract classes do, and you can use an abstract class to do what a lot of interfaces do. There are a few differences. One being that in you can only have one parent abstract class, but you can implement many interfaces.
Okay.
So if you kind of, that makes sense if you think about it, because you can only have one parent class. So if your parent is an abstract class, that's like what you are, but an interface is like kind of things that you say you're gonna do, and then that you implement. So yeah, that's one difference. And you extend and instead of so an example is the list interface. Have you when array list you use the list interface?
Yeah.
If you remember.
Mm-hmm.
So so that means so there are a bunch of other types of lists, like linked lists and other lists. You don't need to know them right now, but they also implement the list interface, and that means they can also do those things. Um,
Oh,
so they can also have the same basic list functions like add and like delete, or add and like remove and all those list functions.
yeah.
Um,
Okay. Mm-hmm.
so
So,
and
yeah.
the other thing is um, yeah, interfaces contain like all abstract methods, so you only leave it in this format with
Yeah, there's no.
right.
Yeah.
So in an abstract method, you might have like you can have like 0 abstract methods in an abstract class, or you can have like 1 abstract method and like 10 like fleshed out methods. In an interface, you have to have all your methods be abstract.
Yeah. Mm-hmm.
So let's do this quick example or this quick question.
Okay. So, so interfaces can only contain abstract methods or class constants. Yes. Interfaces can be extended. Yeah. Well, only like one time though. So initiated. Can you initiate an interface?
Um, no, you cannot.
Yeah, that was
I
really
believe.
tricky. I guess only 1 and 2 then.
Right. I think I wasn't sure if you said that interfaces can only be extended once. That's abstract classes. You can you can implement multiple interfaces at the same time.
Oh, okay. Yeah. Okay, makes sense.
And yeah, just kind of you generally want to use a interface when you're trying to say like um, these are like give like basically a list of things you need to do these things, and you don't worry about how they're done or anything. In an
Yeah.
abstract class, you're more saying like this is of type this, and this is how this is
Mm-hmm.
kind of.
Oh, okay.
Okay.
That makes sense.
All right,
Mm-hmm.
so I'll it's all past 8 now, so we can finish up. Any last questions or anything else?
I have one question.
Sure.
So, like, if you say like a class, like class A, like extend, like let's say like class B extends A, right?
Hmm.
How is that different from class B implements A?
Uh, so implements you use for interfaces and extends you use for classes.
Oh, okay. Because we're basically saying the same thing. Because that's like a subclass of that
Hmm.
thing, right?
Yeah, kind of.
Okay, I just wanted to get that clear. I understand now.
Hmm.
Yeah. Well, that's pretty
Okay.
much it.
Yeah. We next week we have like a spring break for us, so we might not be holding webinars, but you can shoot us questions if you have any on the group me or individually,
Okay.
and then we can answer them.
Yeah, that's
But
fine.
again,
Thanks so much. I appreciate it.
thanks for coming.
Bye.
Take care.